You can see before you this goofy little drawing that I made in Microsoft Paint, and it's going to help us understand how capacitance works. So I'm going to explain a little bit about what capacitors are and what they're used for and how they function. First of all, capacitance is the ability to store electric energy in a device. And we store that energy so that it can be used later in the circuit. It doesn't produce energy. It's not a battery. It's not a voltage source. It's just a place where we can put voltage, where we can use it for later. Now, if you remember, voltage is electric pressure. It's a force that's pushing through a circuit. It's what's providing the pressure to move the electrons around and have them do work. And right now, I've got my voltage at the start of this circuit 0, which is the same as the voltage at ground. So there's no potential through here. And I have this device in the middle here, and this is going to act as a capacitor for us. Very simply, it's just two conductive plates that are separated by an insulator. We call that insulator a dielectric. Maybe a piece of plastic and two pieces of tinfoil would work just fine. And the way this functions is that once I have a potential that's different, so let's say I have 10 volts over here and 0 volts over here. I have pressure now pushing down this way. If we're talking about conventional theory, what's happening is the electrons are running away. They're being sucked up into this voltage source, which is causing current of positive holes to flow this way. So our current is going to come down this way. So if electrons are leaving from this side because they're being sucked up into this plate and into this voltage source, this plate is becoming more and more positive. Now, if you remember, charges have a field that surrounds them, and that field acts on other charges. So positive charges repel positive charges, and they attract negative charges. So as this plate gets more and more positive, this plate becomes more and more negative because these positive charges are repelling these positive charges and causing them to flow this way down through the circuit. And it's causing electrons to come up. It's causing electrons to come up this way to feed this plate. And this plate starts getting more and more negative as this plate gets more and more positive. And it'll continue to do that until it reaches this 10 volts of pressure pushing on the plate this way, or sucking electrons up this way, depending on how you want to think of it in conventional theory or electron theory. What that does is it creates this potential energy difference between these two plates, lots of positive on this side and lots of negative on this side. And so when this voltage source is negated, if I pull this voltage source away, then electrons are going to come rushing back to these positives. And electrons are going to go rushing away from these positives. And you can see we can get voltage returned to our system. If this goes away, the voltage is going to come from this plate and move backwards through the system. And electrons will, electrons will come running back out on this side again. Now, if you remember, charge is measured in coulombs, and voltage is that pressure that's pushing on this plate here. And so we rate capacitors in a unit called farads, and farads are measured by coulombs divided by volts. So the amount of volts that are pushed in here builds up a charge, and the amount of charge that builds up divided by that voltage is the capacitance of this whole capacitor here. Now, the ability to carry that capacitance is affected by a couple of things. It's affected by the area of this plate, so the amount of space that that charge has to build up, and it's also affected by the distance that these two plates are held apart by the insulator. So if you remember, charge, the strength of that charge is going to dissipate by the square of the distance. So every time the distance doubles, the charge is going to be a quarter of what it was at the nearer distance. So this distance really makes a big difference about the capacitance of the unit that we have here. Now, another thing that we have to worry about is the voltage rating of this capacitor. This pressure right here can be so great that it burns a hole through our insulator and is allowed to create a connection between these two plates, and that ruins its capacitance. The whole key is to keep these two plates separate from each other. So it is possible that this voltage gets so high that it's able to jump across to the other plate, and then it's no longer being capacitive at that point. So when you're picking a capacitor, there's a voltage rating for the capacitor, and that's to tell you how much voltage we can push in here before this dielectric fails and electrons are allowed to jump back and forth between the two plates. Now, we can make one of these with stuff that you have at home. All you need is a dielectric, a plastic jar, a Snapple bottle, something made out of glass, and you need to have some tin foil. Now, if you line the outside of this with tin foil and put tin foil on the inside, you have a capacitor. If you connect that inside tin foil with a wire to the outer end here and maybe put a nail in the top or a pin or something, you can charge that capacitor and learn how this all works. I kind of went a little overboard. I made a capacitor out of a 5-gallon bucket. So the area of this plate on the outside and the area of the plate on the inside is going to store a heck of a lot of charge. And I measured it with my multimeter, and I've got 3 nanofarads of charge. I made another one that was like this, that was only 1 nanofarad of charge, and I was able to put a charge through 5 of my students all holding hands. I felt the current go through all of them, with one of them holding one plate and the other one touching the top plate. So we can store a good amount of charge in our little thing here. And the way that you charge it is with a little piece of PVC pipe and something to rub that pipe with to generate static electricity. So static electricity from the outside of the pipe will run into your capacitor through the electrode that you have on the top, and you can charge up the 2 plates. So I don't know if Gary's going to offer you extra credit for it, but I bet it would be cool if you guys made some of these at home and tried them out and showed us a little video or post a picture of it and tell us your results.